will hear a conversation between Harry and Andrea, two students who have just finished their final exams. First, you have some time to look at questions 1 to 5. Listen carefully to the conversation and answer questions 1 to 5.
Hi Andrea, how are you feeling now that exams are over?
It's fantastic to have finished, isn't it? And to sleep in every morning. What about you?
Well, I've been catching up on sleep too, but I've got a lot to do before I leave for England. Perhaps you could give me some advice. I've got a lot of things I can't possibly take back with me, but I don't know what to do with them.
Well, it depends on what sort of things they are and whether you're thinking of giving them away or selling them.
Well, almost everything. Furniture, the fridge and other kitchen stuff that I bought from the previous tenant. But the new people have already got what they need, so they're not interested in buying stuff from me. I can't afford to give it away, but I'm not sure how to sell it all. Oh, and there are some clothes and books as well.
Why can't you take them?
The books are really heavy. It's so expensive if you exceed the airline baggage allowance. And the clothes just won't all fit in my suitcase. It's amazing how much stuff I've accumulated since I've been here. Anyway, I don't think I'll need as many summer clothes in England as I have here in Australia.
I see. Well, there are several alternatives. First of all, you could put up notices around the university about the books. You know, on the notice boards in the Student Union building and in the economics department. Anywhere second and third year students will see them. People are always keen to buy cheap textbooks.
OK, what should I say on the notices?
Just put the titles, authors and price you want, your name of course, and maybe put your phone number on those little tear-off tags.
That's a good idea. And what about the furniture?
You could try doing the same thing, but usually students are away all summer, so they don't want to buy furniture now. Another place to try might be a second-hand shop. Someone from the shop will usually come around and give you a free quote, and then you can decide. But you don't usually get much money for that sort of stuff.
Before you hear the rest of the conversation, you have some time to look at questions 6 to 10.
Another alternative is to put an advertisement in the Trading Post. Do you know that paper? It comes out every week advertising things people want to sell. You have to pay to put the advert in and then hope people phone. Give them as much information as possible, and if they're interested, invite them to come and have a look. The hard part is agreeing on a price.
No, I haven't seen the Trading Post, but I should have a look at it. And I could advertise the fridge, the microwave and the furniture. But the kitchen stuff isn't really that good. You know, old cutlery, a few pots and pans and some plates and things. What shall I do with them?
Well, another option is to donate the kitchen things to a charity shop. You know, like the Salvation Army or St. Vincent de Paul. Why don't you get a second-hand shop to give you a quote first?
Yes, I could do that. Find out how much they'll give me and then decide whether to sell them or give them away. But I've still got the clothes.
A charity shop will take them too, as long as they're in good condition. And even though you don't get any money, at least you know that someone who really deserves some help has benefited.
That's a good point. I'll advertise the expensive stuff, the furniture, and donate the clothes and kitchen stuff. Let's go and buy a trading post and you can help me write the advert.
Well, actually, I'm interested in buying the fridge and the microwave, depending on the price, of course.
OK, let's see how good you are at bargaining.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2.
You'll hear a radio program on the process of making beer.
First, look at questions 11 to 14. Listen carefully.
Hello and welcome to Gourmet Evening, and this week we're looking at the world's popular beverage, a great favourite today, beer. And in the studio to tell us all about it is Clark Maxwell.
Beer is one of my personal favourite beverages, and I've got a number of facts, tips and trivia about beer to share with you. So, who invented beer and when? What is beer made of? Actually, historians are not entirely sure when beer was invented, but they guess that beer was created accidentally by early nomadic tribes roughly 10,000 years ago. The 4 primary ingredients are malt, hops, yeast and water. Malt, which gives the beer a sweet taste, is made from barley soaked in water until its husks open and sprout. The sprouts are then dried and crushed. The small flowers of the hops vine are added partly because they taste bitter, helping balance the sweetness of the malt. Hops prevent the growth of bacteria that can spoil beer. Yeast is responsible for fermentation, which creates the alcohol and carbonation. Beer makers sometimes use additives or substitutes for malt or hops. Substitutes such as corn or rice can make a beer lighter or cheaper to produce.
Before the broadcast continues, look at questions 15 to 20. You will now listen to the second part of the talk.
Adding fruit gives beer a fruity taste. Beer is not high in alcohol, as we know. The lowest type, light beer, contains no more than 2% alcohol, and the highest may reach 6%. Other drinks such as wine are more alcoholic. Wine contains 8 to 20% alcohol. But that is not to say drinking beer is no danger at all. Like all alcoholic beverages, beer can make it difficult to drive and think clearly. Excessive drinking can also lead to liver damage, high blood pressure, stomach ulcers, and other health problems. However, beer also helps prevent some health problems when consumed in moderation. Beer contains a moderate number of vitamins and minerals. Studies have shown that small amounts of alcohol can reduce the risk of heart disease. Beer also contains selenium, a mineral that promotes bone growth and helps reduce the risk of osteoporosis. I suppose many of you think beer can give you a beer belly, but you are mistaken. Genes determine how fat is deposited. No food or drink can create fat deposits in specific areas of the body. As with all foods, the more calories you consume, the more likely they are to be stored as fat and cause weight gain. Beer contains no fat and averages 150 calories per serving. Well, one more thing. Pay attention to the storage and containers of beer. They will affect its taste. It's a mistake that the taste of beer improves with age, like that of some wines. Beer is a food product that will eventually become stale. It should be stored in a cool, dark location before consumption. And the colour of a bottle can influence the flavour. Brown bottles block out light that reacts with the hops, which could damage the flavour. Green or clear bottles provide little or no protection from light damage. Do you know which country drinks the most beer? Although Britain is even on the list of big consumers, actually the Czech Republic consumes the most beer, at 156 litres per person per year, followed by Ireland and Germany.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3.
Part 3. First, you have some time to look at questions 21 to 26. Now listen carefully and answer questions 21 to 26.
Good evening, and welcome to this month's Observatory Club lecture. I'm Donald Mackey, and I'm here to talk to you about the solar eclipse in history. 1,000 years ago, a total eclipse of the sun was a terrifying religious experience. But these days, an eclipse is more likely to be viewed as a tourist attraction than as a scientific or spiritual event. People will travel literally miles to be in the right place at the right time to get the best view of their eclipse. Well, what exactly causes a solar eclipse? When the world goes dark for a few minutes in the middle of the day. Scientifically speaking, the dark spot itself is easy to explain. It is the shadow of the moon streaking across the earth. This happens every year or two, each time along a different and, to all intents and purposes, a seemingly random piece of the globe. In the past, people often interpreted an eclipse as a danger signal heralding disaster, and in fact, the Chinese were so disturbed by these events that they included among their gods one whose job was to prevent eclipses. But whether or not you are superstitious, or take a purely scientific view, our earthly eclipses are special in 3 ways. Firstly, there can be no doubt that they are very beautiful. It's as if a deep blue curtain had fallen over the daytime sky as the sun becomes a black void surrounded by the glow of its outer atmosphere. But beyond this, total eclipses possess a second, more compelling beauty in the eyes of us scientists, for they offer a unique opportunity for research. Only during an eclipse can we study the corona and other dim things that are normally lost in the sun's glare. And thirdly, they are rare. Even though an eclipse of the sun occurs somewhere on Earth every year or two, if you sit in your garden and wait, it will take 375 years on average for one to come to you. If the moon were any larger, eclipses would become a monthly bore. If it were smaller, they simply would not be possible. The ancient Babylonian priests, who spent a fair bit of time staring at the sky, had already noted that there was an 18-year pattern in their recurrence, but they didn't have the mathematics to predict an eclipse accurately.
Before you hear the rest of the talk, you have some time to look at questions 27 to 30. Now listen and answer questions 27 to 30.
It was Edmund Halley, the English astronomer, who knew his maths well enough to predict the return of the comet, which incidentally bears his name, and in 1715 he became the first person to make an accurate eclipse prediction. This brought eclipses firmly into the scientific domain, and they have since allowed a number of important scientific discoveries to be made. For instance, in the eclipse of 1868, two scientists, Janssen and Lockyer, were observing the sun's atmosphere, and it was these observations that ultimately led to the discovery of a new element. They named the element helium after the Greek god of the sun. This was a major find because helium turned out to be the most common element in the universe after hydrogen. Another great triumph involved mercury. I'll just put that up on the board for you now. See, there's Mercury, the planet closest to the sun. Then there's Venus, Earth, etc. For centuries, scientists had been unable to understand why Mercury appeared to rotate faster than it should. Some astronomers suggested that there might be an undiscovered planet causing this unusual orbit, and even gave it the name Vulcan. During the eclipse of 1878, an American astronomer, James Watson, thought he had spotted this so-called lost planet. But alas for him, he was later obliged to admit that he had been wrong about Vulcan and withdrew his claim. Then Albert Einstein came on the scene. Einstein suggested that rather than being wrong about the number of planets, astronomers were actually wrong about gravity. Einstein's theory of relativity, for which he is so famous, disagreed with Newton's law of gravity in just the right way to explain Mercury's odd orbit. He also realized that a definitive test would be possible during the total eclipse of 1919, and this is indeed when his theory was finally proved correct. So there you have several examples of how eclipses have helped to increase our understanding of the universe. And now let's move on to social.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4. You will hear part of a lecture about a crater in Australia. First, you have some time to read questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Lake Acraman in South Australia is Armageddon for the purist. No other meteorite impact on Earth has stamped the surrounding rocks with such an abiding, unequivocal geological record of collision, earthquake, wind, fire and tsunami, the giant waves formed by major Earth movements. The story it tells is elemental, without dying dinosaurs or even Bruce Willis to complicate its simple message of destruction. First, the numbers. About 590 million years ago, a rocky meteorite more than 4 kilometres across and travelling at around 90,000 kilometres an hour slammed into an area of red volcanic rock about 430 kilometres northwest of Adelaide. Within seconds, the meteorite vaporised in a ball of fire, carving out a crater about 4 kilometres deep and 40 kilometres in diameter, and spawning earthquakes fierce enough to raise 100-metre-high tsunamis in a shallow sea 300 kilometres away. Ancient, stable and unglaciated, the bedrock of Australia preserves some of the most photogenic impact craters in the world. Acraman is not one of them. 500 million years of erosion has taken its toll. A salt pan surrounded by low hills is all that remains to mark the site of the cataclysm. The true nature of the place dawned on geologist George Williams of Adelaide University in 1979. Gazing at a sheaf of newly acquired satellite images, he saw the small circular shape of Lake Acraman surrounded by a ring of faults and low scarps 40 kilometres across, and an outer ring twice this size. A year later, he made it to the site. On islands near the centre of the lake, Williams found bedrock shattered in a conical pattern that experts consider a sure sign of a meteorite impact. Except for a crater, which had long since eroded, the area was a textbook example of an impact site. In 1985, further intriguing evidence turned up. Vic Gostin, another Adelaide geologist, had been studying a thin band of fragmented red volcanic rock in 600-million-year-old shale in the Flinders Ranges, more than 300 kilometres east of Acraman. To his bewilderment, the volcanic chunks turned out to be 1 billion years older than the shale. Where had they come from? Comparing samples, Gostin and Williams found that their rocks were identical. The red rock in the Flinders Ranges had been blasted there from Acraman. Later, the same material turned up at sites 500 kilometres from Acraman. Everywhere, the bands of fragments showed the same structure. Coarse pebbles at the bottom, then a cocktail of silt and sand, then layers of increasingly fine sand distorted on top into a wavy, scalloped pattern. These layers also show, step by step, how the meteorite transformed the floor of an ancient sea hundreds of kilometres away, according to Malcolm Wallace of Melbourne University. First came the earthquake. Travelling at about 3 kilometres a second, shock waves arrived offshore within a minute or two of the collision, stirring up the water with clouds of silt as the seabed shook. Then shattered rock from the explosion arrived by air. Pebbles and boulders crashed into the water, reaching a depth of about 200 metres within a minute. One day they would become the lower band of the Flinders Rock. Sand took up to an hour to come to rest, finally bedding down with the silt that was also now settling on the sea floor as the effects of the earthquake died away. This mixture would eventually form the next layer. About an hour after the meteorite's impact, huge waves rolled in, leaving the ripples on the surface that later hardened into rock. Clear as mud is not an oxymoron. In Acraman, the arid, timeless Australian outback has preserved the closest thing the earth can boast to a perfect pockmark, the pinnacle of imperfection.
That is the end of part 4.
You now have half a minute to check your answers.
Hello everyone, welcome to our channel. Today in this video I'll discuss with you writing task 1, and the question for today is: the graph below shows the way people of Canada invested their money in stock market during the year 2011 to 2016. Summarize the information by selecting and reporting the main features and make comparisons where relevant. So we are given this graph in which the amount is invested in stock market by the Canadians, and the amount is in billion, and the years are 2011 to 2016. This line 1 is representing bonds, and this unshaded or black one is representing the stocks. So as we can see, as compared in each and every year, the investment in stocks was higher than in bonds, right? And one more thing can be noticed here, like as the time passed, or after a year and year, both the bonds and the stocks investment showed or witnessed an increasing trend. So let's see how we can write this now. The rendered bar graph depicts the money invested by Canadians in the stock market from 2011 to 2016. Overall, it is discernible, means clear from the graph, that the investment was higher in stocks as compared to the bonds during 6 years. So as we have already discussed that. Explicitly, the amount invested in bonds and stocks increased throughout the given period. In 2011, stock purchase commenced at 2010 billion, which was almost double the bonds investment of 100 billion. So here we can see like the stocks, the purchase of stocks began at 210 in the year 2011, and it was almost double the investment of bonds, which was 100 billions. After a year, the funding in stock slightly increased by 6 billion and reached 227 billion in 2013. So after a year, what happened? The funding in stock increased by just 6 billions, like from 2010 to 2016, and then in 2013 it reached at 227 billion. However, bond financing rose to 123 and 157 billion in the respective next 2 years. So in the next 2 years, the bonds investment increased to 123 billion in 2012 and 157 billion in 2013. In 2014, the purchase of stock was 289 billion, which surged slightly to 297 billion in 2015. So we can see here in 2014 the investment in stock was 289 billion, which increased slightly to 297 in 2015, and the investment peaked at 311 in the year 2016, or in the last year. In the last year, the investment in stocks peaked at 311 billion. The flow of funds to bonds, if we talk about bonds, the flow of funds means the investment was 162 billion in 2014, which then steadily grew to 179 billion in 2015. So if we talk about 2014, it was 162 and increased to 179 in we were talking about the year 2014, and it was 162 in 2014 and increased or grew to 179 billion in 2015, before peaking at 188 billion in the last year of the period. So before reaching at or peaking at 188, billions in the last year. It was 179 billions in 2015 and 162 billion in 2014. So this was for today. If you like the video, do hit the like button and subscribe to our channel. I'll meet you in the next video. Till then, bye and take care.